Okay, so before we start presenting, I just want to give a huge shout out to everyone at AI Camp who made this experience possible, especially to our instructor Chase, who was absolutely amazing and couldn't have done this without him. So our product is called Detoxify, and I'm Arhant, and I'm the machine learning engineer.
I'm Toryn, and I'm the front end developer.
I'm Ayush and I'm the data scientist.
I'm Michael and I'm the backend engineer.
I'm Sravya and I'm the other data scientist.
I'm Jacky and I'm the product manager.
So the reason we decided to build this product is because there's a problem. Thousands of people get bitten by snakes or ingest poisonous mushrooms. So a lot of these situations can be dealt with our product Detoxify. And our secret is identification and information. So Detoxify uses machine learning or computer vision to identify the species of the photo someone uploads, and then provides the best information on preventative and treatment steps, along with helpful and other interesting information. Through Detoxify, we hope you can stay safe and poison-free. So just a quick overview of computer vision for the NLP people. So computer vision is basically a program that uses machine learning to detect and classify objects in an image. So as you can see in the example we provided, you put in labeled data, such as you labeled circles and you label rectangles, and you put it into an untrained artificial intelligence model. And then you let it run, and it detects patterns in the objects, and it becomes trained. Then a user can input an image, and it'll predict what's in that image. So for our product, we inputted thousands of labeled images of snakes and mushrooms with their corresponding species labeled. Then we trained the AI model YOLO v5 to recognize patterns between these different species. So now I'm going to head it over to Ayush, our data science, to talk about accuracy and limitations of our product.
So one of our biggest limitations with this model was the limited species that we have. Due to time constraints, our AI model can only detect 21 total species. This includes 11 snakes and 10 mushrooms. Despite this, we are very proud of our model because of its high accuracy. We trained our model on over 5,000 images of snakes and mushrooms for over 10 epochs or iterations. Our model consistently predicted the right species in the image with over 95% accuracy during our best epoch. However, there are many species that we didn't train on, and it may classify a snake that it hasn't been trained on as one that it has been trained on. To counter this, we added lots of augmented images that truly prepare our model for real-world applications. And to go more in depth on that, I'm going to pass it on to the other data scientist, Sravya.
So, as Ayush said, image augmentation is a crucial step to ensuring the success of our model. So, augmented images are basically used for creating more data for the model to train on. It's important for making an accurate model, but providing more examples to train with. So, in our model, we had almost 100 images from different angles and environments per organism. Also, adding noise is really important. It's basically used to test the robustness of the model and how it performs. So in this model, adding noise helps stimulate bad camera quality. And then lastly, brightness levels are also essential to stimulate the lighting of the images. But to really make sure our model was robust, we added pictures of other aspects of nature. So things that the model couldn't really identify, such as dirt, plants, and other reptiles, to basically train the model to know when there's no target in the photo. This made sure that the model didn't mistake certain background textures for an organism. So now I'm going to hand it over to Toryn and Michael to demo our model.
All right, so I'm going to go to our homepage where we have a nice little upload section where you can upload a photo and get the results. I have a few photos here of a few species we trained it on. First thing I'm going to do is I'm just going to upload a photo of, let's say, a gopher snake. It's going to upload the photo and then immediately get our information. On the left is a picture from Google. On the right is the picture that you uploaded with a bounding box on it. Bounding box is just like an outline of the recognized stuff the convolutional neural network recognized. It gives its confidence score, the species name, description on it, whether it's poisonous or aggressive, images, an article on it, preferably Wikipedia, preventative steps on what to do if you're near it and it could be dangerous, And if a snake has bitten you or you consumed a mushroom, it gives you some more information on what you should do. We also have a warning at the bottom here, just in case someone is in an emergency, opens this website up on their phone, and let's say and just got bitten. They have an easy way to call the Poison Control Center. Now I'm going to try and do this now with a mushroom, for instance. Here we go. It uploads it, and here it is, more information on it. And then for our last photo, I'm going to try something that's an iguana, which it shouldn't recognize. And as you see, error, subject not found, and our AI was not confident enough. But to show how this was done, I'm going to pass it off to my teammate Michael to explain the back end.
So for our project, we use the Python framework Flask because it's very lightweight and easy to use. So this is how it can connect with the client, where you send the image when you upload it from your computer or phone. So after you upload the image, it goes to our server where you can, we're using PyTorch. It goes to our best model that we trained multiple times, and then once it gets the data from the snake or mushroom that it was found, it also gives us a confidence level, and the highest confidence goes to our custom database where we have like tons of information about each insect that we trained. Torrens, all this information, and then that goes all back to the client where Torn handles the distribution of that JSON data into the client HTML. And since ours is a bit different, because we did it all on a single page, Torn's going to explain that a bit more.
Yeah, so a quick recap is that a lot of you CV students especially probably notice it's just a single page rather than redirecting you. Basically, I'll just do this quickly so we don't run out of time. Our front-end JavaScript, you can create form data using a class, and instead of using an actual HTML form, that form data is then, the file uploaded is then appended to that form data. It then sends a post request to our backend, and then the backend responds with a resolution with the JSON formatted data from this database here. And then a bunch of this is just animation, and that's the basic outline of how we did that without the redirection. I'm now going to pass it over to Jacky, and he can close this out.